Our next startup to pitch is going to be Hago Energetic Benefit Corporation, mentored by Sheila Marshman. Hago Energetics uses innovative decarbonization technology to convert animal and agricultural waste into green hydrogen and biochar. Hydrogen is something near and dear to me, so that's cool. They're based in Camarillo, California. Wilson Hago will be presenting for Hago Energetics. Please welcome Wilson to the stage. Come on up. All right. Congrats. Bring it on up. Here's your clicker.
Good afternoon. Our company is about creating an abundant future. Now, I grew up in Ecuador, South America, and what I recall from being as a child is that we didn't have very much, but there was this feeling of abundance. There were a lot of trees around, there was lots of fruits and vegetables. There was no feeling of this scarcity. Recently, the news is all about drought, scarcity, the nasty consequences of climate change. So our efforts are geared toward creating an abundant future like the one that I grew up with. So one feature of abundant systems is that the output of one serves as the input of another. So this is illustrated, for example, as you see here, is a cow. The output of a cow can actually serve to power a space shuttle station because you can make hydrogen and make hydrogen from cow manure. Similarly, you can make hydrogen from cow manure to power a hydrogen fuel cell bus. So it turns out that methane is a problem, it's a very global problem. Methane is generated from cow manure. For example, in the pit that you see behind me, methane just evaporates or is generated from this just upon the decomposition of organic matter. This methane is actually very nasty for the environment. It can be a very potent greenhouse gas, about 100 times as powerful as carbon dioxide. So this methane has been accumulating for the past, since the Industrial Revolution. As you can see here behind me, the levels have been fairly constant except for the past several decades where the methane as a result of increased agricultural production, also fracking, and other industrial processes. So we need to solve this problem because it's a nasty problem, this methane problem. So our solution is to convert this methane, to turn waste material to hydrogen, or to turn cow manure to money, cow manure to cash. Okay, how do we do this? We start out with the cow manure, we aggregate it in a box called a biodigester, let the gas build up, take this gas that builds up to our proprietary reactor. What the reactor does is to convert the methane to hydrogen and carbon. The hydrogen can be sold to industrial customers or used within the farms, and then the carbon can go back to the farm as, for example, compost material. That is the basics of our solution. An implementation of this can be seen here. For example, you have a farm, you can build a biodigester and then route the biogas to our facility where it's converted to hydrogen and carbon. So today, we're actually doing this in the state of California. We're working on a project. This is our pilot project that's funded by the California Energy Commission. What you see on the left is a biodigester presently on the farm. We're working with one of the largest farms in the western United States. The biogas is being routed through the pipes, and then ultimately we'll be draining some of that biogas to our reactor. And then we'll be creating hydrogen and carbon. The hydrogen is going to be sold to transit authorities that operate hydrogen fuel cell vehicles, and then the carbon is going to go back to the farm and used as compost. In our travels through this region, we have identified several project sites. On the left, you see Hago Farms. They're a farm in Pavilion, New York. It's owned by Steve Gould and his dad, John Gould. It's a farm of about 250 cows. It's a typical size farm. Steve is interested in converting the waste materials into something useful and generating electricity for his own needs. And so he's very interested in decarbonizing his farm. Similarly, on the right-hand side, you see Stein Farms in Lurie, New York. It's owned by Ray Stein and his wife, Shelley. They have a farm of about 1,000 cows. Ray is interested in, basically, he has a biodigester on site, and is interested in using hydrogen so that he can buy, he's very interested in buying a hydrogen tractor and using and decarbonizing his farm. 20 miles away from Stein Farms is it's Plug Power. Plug Power is bringing 400 jobs to the region. So we will be supplying hydrogen for fuel cells such as produced by Plug Power. And our hope is to actually bring in more than the 400 jobs that Plug Power is bringing to the region. So besides a farm environment, we can also treat the methane that arises from wastewater treatment plants. There are 16,000 wastewater treatment plants in the US and over 1,000 landfill facilities. We can equally treat both of these. We have gone to SUNY Morrisville wastewater treatment plant. We're about to sign a letter of intent with them. We've actually, before, as I mentioned, with the dairy farms, we have signed a letter of intent with Hago Farms. The landfill facility that you see here is in Canastota, New York. The hydrogen markets are significant. The total addressable market is over $100 billion. It's because hydrogen is used in a variety of different industries. It's used to make ammonia for fertilizers. It's used in steel production. It's used in cement making and transportation. Our initial focus is going to be on the transportation. 95% of today's hydrogen comes from fossil fuels. So our approach is to bring green hydrogen to this field, starting with agriculture. So you may have heard that the New York State is very interested in joining the hydrogen economy. It's signed an agreement to be in part of the regional clean energy hydrogen hub with neighboring states such as Massachusetts, New Jersey, Rhode Island, and Maine. This is the source of green jobs for the future. And so to minimize our hydrogen transport in the beginning, we're going to be part of this ecosphere, but in the beginning we're going to be having to use the hydrogen within the farm itself. So for example, to power a power station in the farm, or power a hydrogen tractor or other farm equipment. In addition to the hydrogen, we will also be generating carbon. An interesting feature of our solution is that we use biochar in our process, and the carbon from the methane lands on the surface of the biochar. But the biochar is used as a soil amendment. And so, as you know, biochar has been extensively studied at Cornell. Professor Johannes Lehmann is one of the world experts in biochar. It has many benefits for agricultural use. And we plan on basically returning the biochar after we've done with the hydrogen conversion back into the soil. The problem with biochar today is that it's too expensive. Most farmers just cannot afford it. So our business proposition is basically to sell the biochar at prices like mulch, so that it is readily accessible to farmers, and just charge market rates for the hydrogen. Our aim is to bring the technology that we're building in California to the Grow New York region. So we want to launch a pilot here in the Grow New York region. It's going to cost $1 million, $250,000. It's going to allow us to hire a manager on site, and then the other $250 will allow us to buy the equipment, and then the rest of the $500 will allow us to it will be used for operations. Ultimately, we will be building a large commercial facility that's going to be creating direct and indirect jobs of over 200 people. And this number comes as a result of looking at the multiplying effect for durable manufacturing from the Bureau of Labor Statistics. So we've looked at other competitors in the field. There are people that are converting methane to hydrogen. They're all basically starting with natural gas. We are the only company that's has agricultural benefits, has low cost, has actually a carbon negative footprint, and we're using nature-based catalyst for a process. So our team, we're comprised of a variety of professionals. We've had extensive industrial experience. We've been at this for several decades in industry. We are ready to work hard to deploy this technology in New York State. I grew up in the Bronx. I went to the Bronx High School of Science, and doing a project here in New York is like returning home. So I want to thank you for the opportunity to present our vision and execution plans. And particularly, I would like to thank Professor Sheila Marshman for being our mentor. Thank you.